Hi, in this series of videos, we will have a look at the wind energy kit that's standing right next to me and what goes inside the kit and how it works. This is a kit manufactured by Thames and Cosmos and can be used by children above 8 years of age. In the first section, we will have a look at what are the parts that constitute this windmill. This windmill consists of three major components: the wind turbine blades, the gear system, and a DC generator. These three together constitute the windmill. The way it works is, a gust of wind will come and hit the turbine blade, causing it to rotate. As a result of the rotation, the gears here will turn the shaft that is attached to the DC generator. The generator, in turn, will generate a DC current here, which will charge a battery unit, as you can see. The gear system in this particular case has three options. We can have a 3:1 gear, a 1:1 ratio, or a 1:3 ratio. Depending on the wind velocity and the direction of wind, we have to decide which gear combination to use. The gear system will determine how much current is being generated through the DC generator, and that in turn will determine how long does it take to charge my battery up here. This is the gearbox. The gearbox plays a very crucial role in the entire windmill system. The way it works is, you have two wheels rotating which are in sync with each other. In this particular gearbox, we have three sets of such wheels. On your left, you have a combination of a red and a yellow. In the middle there are two blue wheels, and on your right are a red and a yellow wheel. The radius of the red wheel is 1 unit, the radius of the blue wheel is 2 units, and the radius of the yellow wheel is 3 units. As we know, the circumference is directly proportional to the radius. So, for every 3 rotations of the red wheel, you have 1 rotation for the yellow wheel, for the gear system on the left hand side. Similarly, for every 1 rotation of the yellow wheel on the right hand side, you will have 1 rotation for the red wheel on the right hand side. The number of turns per second determine how much current is being generated through the DC generator. So, if I have a very strong wind, I would prefer to have more number of rotations with the turbine blades and have a steady current flowing. And my choice would be a 1:3 gear ratio. For situations in which I have a very slow wind, I would prefer a 3:1 ratio in the gearbox, which will again lead to a very steady current out of the DC generator.